Chicka chicka pow pow! What's up, my peoples? Mr. Wagner here, ready to do some math. Let's get into this. CTM chapters 5 and 6 review for part 1. We're going to have a test on 5.7, 5.8, and 6.1 to 6.4, and that is a fire alarm test right there as well. So, hey, 2 tests going on at the same time. That's amazing. I'm going to pause the video and wait for that fire alarm to be done. I believe the test is over. We will see. There might be another fire alarm test in just a moment, but let's just start working on the problems at this point. So number 123. Is that a siren in the background? What is going on? Oh my gosh. Okay, so I hear a police siren or ambulance siren in the background now too. Whatever. Focus! We are focused on math right now. We are ready to do this. The exercise is 123 to 128. Determine whether the sequence is arithmetic or geometric. Then determine the next 2 terms of the sequence. I was almost going to do all of them. I just need to do the evens because that's what I have assigned. If you want to try the odds, you're welcome to do that. But you can find all the answers to these review questions in the back of your book. But this one, let's look at these 3 in particular. So we're looking for either a common difference or a common ratio. If we're multiplying by the same thing every time, that's geometric. It's a common ratio. If we're adding the same thing every time, it's a common difference. That's arithmetic. So here I noticed I'm adding 3. That would be arithmetic. But right here, I'm taking each value, multiplying it by 2, not by 1/2, but by 2. I'm getting the next term. So this times 2, same thing again, times 2, 2 times 2. So this one has a common ratio. It is geometric. So this one would be geometric. And determine the next 2 terms. So multiply by 2 again. The next 2 terms would be 8, and times 2 one more time, 16. So that's for 124. 126. See what we got here. It looks like I'm multiplying the bottom by 2, which would be the same thing as multiplying by 1/2. So here I have a ratio of 1/2. Here the ratio was 2. So this one is still geometric because you're multiplying by the same number every time to get the next term. Multiply this by 1/2 again, and you'd have 1 over 32, and then one more time, you'd have 1 over 64. And finally, 128. It looks like in this one, it keeps going back and forth between positive and negative, but it still stays 2 every time. So if you were to multiply by -1 and just keep doing that, it would keep flip-flopping back and forth like that. So we'd have a ratio of -1. It's not a common difference because you're not adding the same thing every time. This is geometric, and so the next 2 terms would just be -2 and +2. It would keep flip-flopping back and forth like that. So let's move on. These are this one. These are all arithmetic. You can try those if you'd like to on your own time and check and see if you got the right answer in the back of your book. 130, 132, and 134. Still looking at just these even ones. So that's what I have assigned. In exercises 129 to 134, find the indicated term of the sequence with the given first term, A1, and the common difference, D, or common ratio, R. And so for 130, we have a common difference. This is arithmetic then. And we're trying to find A of 8 when A1 equals -6. So the formula here for the nth term, you just take that first term, and to that you're going to add n-1 times that common difference. That'll get you to that nth term. So here, this becomes A sub 8. A sub 1 is 6. The first term is, or -6. The first term is -6. You're plugging in 8 because that's your n value, your nth term, and you're multiplying all that times, so the difference is -4, it says. So multiply that by -4. This would give you -6 plus 7 times -4. That would give you -6 minus 28, and that would leave you with your final answer of -34. 132. Here we have a common ratio instead. So this is geometric. So that formula, we're going to use that first term times, and then we take that times the ratio to the n-1 power. So we just need to plug in, trying to find the 5th term here. So a sub 5, first term is 3, plug that in. I usually use parentheses when I plug stuff in, especially if I'm plugging in negative numbers. That way I know to multiply instead of subtract. And then the ratio here is 2, so I'll plug that in right there as a 2. N is 5, it's my fifth term, so I plug in 5. That is 5 minus 1. And this would leave me with 3 times 2 to the fourth. 2 to the fourth, that would be 16. And 16 times 3, that would be 48. So the fifth term in that sequence should be 48. And then finally 134 with this set. A to 4, we got another ratio problem, another geometric problem. So we use this formula one more time. And we're looking for the fourth term. So that a sub 4, a sub 1 is negative 6. So the first term, negative 6. Ratio is 2 again. And we've got to the 4 minus 1. And so this would be negative 6 times 2 to the third power. 2 to the third power, that's 8. And negative 6 times 8, that's negative 48. Let's check out the next batch. So 135 to 138. Find the sum of the arithmetic sequence. The number of terms n is given. So we're going to look at this one and this one. We have n here and here, so that's important. That's important. For both of these questions, we're going to be using that sum formula for arithmetic sequence, which was you're taking the number of terms, take the first term, and the last term, add those two things together, and divide that by 2. So we're going to use this formula for both. 136. What's the common difference? It looks like we are, since we're going from negative 4 to negative 3 3/4, that's actually a larger number in terms of moving up the number scale, or moving up the number line. So the difference here, we're adding 1/4 each time. It's a difference of plus 1/4. Add 1/4, add 1/4, add 1/4. We're going to keep doing that. And so here the sum of, we're looking for the sum of the first 8 numbers. Take this formula, plug stuff in. And so we've got 8. First term is negative 4. And my nth term, it says, I can assume here, is this one, the number of terms n is given. And is that a safe assumption? Yeah, that's a safe assumption to say that that is the 8th term. So we can say that we're just plugging that in right there. So negative 2 and 1/4. And we got all this over 2. So let's simplify this and see what we get. So this I would have 8 times, and then this plus this, it would be negative 6 and 1/4. Negative 6 and 1/4 right there. Negative 4. And then plus and minus is the same as subtracting. So we can think of it like that. Let's see what I could do here. I could reduce this and this. That would make it a little easier. That would be a 4 and a 1. And so I would just have 4 times negative 6 and 1/4. I think the easier way to think about this is probably as a improper fraction. So take this 4 times 6 is 24, and add 1 to that. You'd have negative 25 on the top. So this is the same as negative 25 over 4. And would you look at that? So this had reduced down to 4 and 1 right here. We can make this a fraction. We could put that over 1 and think of that as reducing down to 1 and 1. So your final answer here, if you add the first 8 terms all together here, we should get negative 25. You could verify that. This one would be easy enough to verify by actually adding all the digits or all the numbers together and see that you get that. But if you get too big, you start to get too many terms, that becomes really, really tedious. That's why we have the formulas. So this one, 38, it looks like we're adding, well, it looks like we're adding the same thing actually. 0.25 is the same thing as 1/4, but we'll just use decimals on this one instead. So the sum of the first 20 terms, I wouldn't want to add these 20 numbers together separately. This one, it might have been faster, just barely, to add these together separately, but here I don't think so. If we plug things in, we're going to have 20 first term, 0.5 last term, or the 20th term, 5.25, divide that by 2. And so we have 20 times 5.75 divided by 2. You could multiply these together and then divide that by 2, or you could make life simpler to start and reduce that first, and so we'd have 10 times 5.75, and that makes it easy to do without a calculator. multiply anything by 10, and you just move the decimal over one spot. And so we have 57.5 for the final answer there. So it looks like we're good to go with those. Let's move on to 140 and 142. 140, 142 here. Find the sum of the first n terms of the geometric sequence for the values of a1 and r. This is a geometric sequence. We're talking about sums now, so we're going to use that formula for the sums of geometric sequences. And I meant to write an S there, sorry. So the sum of the first n terms for a geometric sequence, we take that first term and we multiply that by the quantity of 1 minus r to the nth power, like that, and then we divide all that by 1 minus r. So number 140, let's see what we got. Let's plug the numbers in. So we have n is 4. We are given our first term as 2, so I'm going to plug that in right there. My ratio is 3, plug that in for r, and plug in 4 in for n. And where this is all divided by 1 over 3, or 1 minus 3. This would be 2 times, and this would be 1 minus 3 to the 4th power would be 81. This would be all over negative 2. And this would give you this over this. You could reduce this fraction. You could make this a 1 and a 1. And so you have negative 80 divided by negative 1, which would be positive 80. And so the value for that, that's if you add the first 4 terms together of a sequence where that is true. You should get 80 for your final answer there. 142, this one, we've got n equals 6, a1 is 1, r is negative 2. So I'm just going to plug in 6 for n. a1 is 1, so that's what goes in right here to start. 1 minus, and this will be negative 2 now to the 6th power. Notice I use parentheses there. I got to plug in negatives, especially using parentheses. And this will be 1 minus, and then on the bottom we've got the ratio. So 1 minus a negative 2. Notice that's going to change it to a positive 2, 1 plus 2 on the bottom, which would be 3. So here we'd have, I don't need to think of the 1 on the outside, because 1 times anything is still that same number. But here we'd have 1 minus, I'll keep this in parentheses for now. This and this does not become a plus sign because you have to take negative 2 to the 6th power. The exponents, PEMDAS, comes before the subtraction. E comes before S in PEMDAS. So take 2 to the 6th power to the 4th power, 16 times 2, 2 more times, and give you 64. And so you have negative 63 over 3. That is negative 21. And notice I did those without a calculator. Could you use one on that? Yes, if it was allowed on the test. You will be allowed to use calculators, but you should show me, you got to show me at least that setup if you're one of my students, and show me how you are getting your answers. Numbers 144, 146, and 148. Let's take a look at those even ones now. First determine whether the sequence is arithmetic or geometric, and then write an expression for the general or nth term. So for each one of these, either are we adding something every time, or are we multiplying by something every time? So I look at this first one, 144, plus 3, plus 3, plus 3. This one has a common difference of 3. The second one here, 146, that looks like times 2, times 2, times 2. So this one has a common ratio of 2. You can think of 5 as 5 over 1, and so I notice this one, you're multiplying by, looks like 1/3 on the bottom each time. 1/3 times 1/3 would give you that, times 1/3 would give you that again. So here's what we got. The first one is arithmetic, the other two are geometric. 144 then, we're going to use our formula, which was for arithmetic. We have a sub n is a sub 1 plus n minus 1 times d. For geometric, we have the nth term equals first term times the ratio to the n minus 1 power. So for this first one, 144, we'll use this. For the other two, we'll use this. And so let's see what we got here. We're going to plug in, my first term is 3. So my nth term would be my first term, 3, plus n minus 1 times the common difference is 3. So I'm going to put a 3 there. I can think of distributing this 3. So I'm just trying to simplify this expression on the right side. Just combine like terms from there, and it looks like the 3 and the negative 3 will go away, and so this one, pretty straightforward. The nth term would be 3n. 145, I'm sorry, 146, I'll just turn that into a 6, there we go. 146, we've got this, we're going to use this formula because it's geometric, we got a common ratio, so a to the n, or a sub n is a to the 1, is 3 here, times the ratio is 2 to the n minus 1. Now we can't put these together because the exponents, the powers are not the same, so I have to keep those separate. So you could write it like this. The back of our book writes it like this instead. Both ways, either way would be totally fine by me. So this way or this way, either way is acceptable. So I'll say this, or you could say that right there. And then 148, use the same formula, start with that. A sub n would equal, you got your first term is 5 times the ratio, common ratio is 1/3, and we are raising that to the n minus 1 power, so it would look like that. So if you wanted to write it like that, that's fine. If you wanted to write it without the dot in between, that's fine too. This though we should be putting in parentheses, because otherwise I'm not sure if you're saying just raise the top, the numerator to the n minus 1 power, or the whole thing. We want to raise the whole thing to that power. So either one of those ways is a totally fine way to write that. And now let's check out 150 and 152, and that will be from 5.8 now. So this is reviewing those, or that lesson about the Fibonacci sequence. And here they're asking to tell if this is, or determine whether the sequence is a Fibonacci type sequence. Well, the Fibonacci sequence, that was 1, 1, 2, 3. We're just adding the two numbers previous to that, adding the two numbers previous to that to get the next number, 5, 8, 13, and so on. So we're basically asking here, does that pattern hold where you add the two numbers before it to get the next number? Are you doing that here? Are you adding these two numbers to get this one? Yep. These two to get this one? Yep. Yes, yes. So that holds. Does it hold? Is it a Fibonacci type sequence? Yes. And then what are the next two terms? We'll add these two together. This looks like the Fibonacci sequence right there. I'm doing 149, and I'm supposed to be talking about 150. There we go. So same thing here. This one actually was a Fibonacci sequence, so with an extra 0 added there. Anyways, 6 plus 11, though, let's work on the question I'm supposed to be working on. That's 17. And then 17 plus 11 would be 28. And so my final answer there would be yes. And the next two terms, 17 and 28. 152, let's see, does it hold? Negative 10 plus 10, that's 0. So you might be tempted to say, oh, yep, it holds, we're good. But let's see if it works out. 10 plus 0, does that equal 10? 0 plus 10, does that equal 20? No, this number actually should be a 10. And so if that was a Fibonacci type sequence, because that didn't work out, we would say no. And so this one, we don't have to figure out the next two terms because it's not a Fibonacci type sequence. Now we're going to move on to some questions from Chapter 6. So you can be expected to have to know the stuff from 5.7 and 5.8 and 6.1 to 6.4 for this first part. I'm calling it the Chapter 5/6 test, Part 1. So exercises 1 through 6. With these ones, I had assigned the odds, I do believe. Let me just double check that a second. Yes, that is correct. So I'm going to go over the odd ones. If you want to do the evens, though, for a little extra practice, that would be highly recommended. They're all on the back. All the answers are in the back of your book. So you could check those out if you want to try those too for some extra preparation as you get ready for the tests on this part 1 of chapters 5 and 6. So numbers 1, 3, and 5 we'll take a look at here. Evaluate the expression for the given values of the variable. So we're going to plug in 3 for the first one for x, and just simplify that. This would be 9 plus 12, which would be 21. Final answer for number 1 is 21. Number 3, we're going to take 2 and plug it in for x wherever we see an x there. So we're going to have this for the first step, and then just simplify that. So this should be 4 times 4 right there. 2 squared is 4. Here you have minus 4 plus 5. We want to do our order of operations correctly, so multiplication before the addition and subtraction. So 16 minus 4 plus 5. Yes, addition comes before subtraction in terms of when you write out the word PEMDAS. I can't even spell PEMDAS. There we go. But remember, this is first, parentheses is first, exponents is second, multiplication and division, same importance, whatever order they're in. Division, multiplication, they come third, but you just move left to right. If division comes before multiplication, do that first. If it's to the left, before that. On addition and subtraction, same thing. They're of the same importance, so if subtraction comes before addition, you do subtraction first. If the addition sign was here and subtraction was there, then we do the addition first. Just move left to right if that's all you have left is addition and subtraction. And so this would be 16 minus 4, 12, and 12 plus 5, that would be 17. Excuse me. And number 5, let's plug in negative 2 into this expression. So we have 4 times negative 2 squared, cubed, sorry, negative 2 cubed. We have that minus 7 times negative 2 squared plus 3 times negative 2 plus 1. And so this is going to equal, I would have, this would be negative 2. Any negative to an odd power is always going to be negative. You'll have one negative left over in the end. 2 cubed is 8. And here we'd have negative 7. Any negative to an even power, the negatives will cancel out completely. So you'd have a positive, and then 2 squared would be 4. This would be negative 6. I could simplify that right now. Simplify the multiplication here first. So negative 28 minus, or negative 32, sorry, minus 28. Getting ahead of myself there. Minus 6 plus 1. So now all addition and subtraction is left. That's all we got. Just move left to right. So this would be negative 60. Negative 60 minus 6 would be negative 66. And negative 66 plus 1 would be negative 65. You could write out intermediate steps in between there if that was helpful for you, but I felt like that one, at least for me there, was easy enough to think about in my head. Alright, let's move on to the next batch. We got 7, 8, and 9. We're going to look at 7 and 9 together. So here, combine like terms. This is coming from lesson 6.2 now. So 3x minus 4 plus x plus 5. I'm going to cross some stuff off up here as I go. The 3x and the x. I can put that together, so I'll get rid of that. I'll cross that out. That would combine together to get me 4x. So I've used that stuff, and now I want to combine the regular numbers together, or the constant terms. Negative 4 plus 5, put those together, you'd have a positive 1. So the final answer for number 7 should be 4x plus 1. Number 9, I'm going to write this one out here. I'll show you why in a second. Because I think it's easier to draw this in, or to represent that I'm distributing. Remember, you include the sign as well. Since it's positive, that won't change any of the signs in here. But if this was negative, be careful, that might happen. Then you would have to change the signs of the parts in there. This would just be 4x minus 4. So I'm simplifying this expression. This is not an equation. I'm just saying that this expression equals this expression. This would be 1/3 of 9 would be 3, so you'd have 3x. You can make this a fraction over 1, multiply across, you'd have 9 over 3 and reduce that. But hopefully 1/3 of 9 is easy enough to see without doing that. 1/3 of 3 would just be 1. So let's combine like terms now. 4x plus 3x, that'd be 7x. I've gotten rid of the x's there. Now I'm doing the constant terms. -4 plus 1 would be a -3. So our final answer there should be what you see right there, 7x minus 3. Continuing with now exercises 10 to 14, we'll look at 11 and 13 together here. Solve the equation for the given variable. So I'm going to start by writing the equation that's there. Just write it over again here. And I'll use some different colors for my steps just to make things a little easier to tell what I'm doing. So I'm going to subtract 3t. That gets the t's to one side. So you get the variables on one side, and then you get the constant terms or the regular numbers on the other side. So I'm going to add 13 to do that. So as long as you do the same thing, exactly the same thing to both sides of the equation, you get a valid equation still. It's still going to equal each other on both sides. And here now we can divide by 3 to get a final answer for t of 7. You can easily plug that back in to check your answer. 3 times 7 is 21. 21 plus 8 would be 29. Over here, 6 times 7 would be 42. 42 minus 13 would also be 29, just like it should be. Number 13, again, I'll rewrite the equation for ease of understanding. And think of taking this now. Oops. To get out my red there, the 4, distribute that through, positive 5, distribute that through, and that would leave me with 4x minus 8 equals 3. That's just hanging out there by itself, plus 5x plus 5 times 4, 20. And now we can combine like terms here. I can put the 3 and the plus 20 together, so I'm going to do that right here and right here, combine those together. That's going to leave me with, and this side I don't want to change at all yet. I'm just going to combine like terms first. So I'd have 5x plus, and then this and this together would leave me with plus 23. And so from there, now it's a matter of something that looks like this. Same thing as before. Get your x's on one side. I'm going to subtract 4x because it keeps things positive. I'm a positive guy. I'm an upbeat guy. I like to keep things positive when I can. And it makes the math easier if you keep things positive too. And so plus 23 here, do a minus 23 to get that to cancel over here now. And let's see what we got left. At that point, we would have negative 31 equals just a single x, just one x. I don't have to write the 1 in front. It's assumed it's a 1 if there's nothing there. That then would be your final answer. So number 13, x is negative 31. And again, you could plug that back in. I'll let you do that to verify that here. But I'm going to move on to numbers. Did I skip 15? Uh-oh, where's number 15? I'm going to have to write that one in. So I will put a page before this, and I'll just write out what number 15 says in the book. I thought I had it, but apparently not. So we were making some oatmeal. It says a recipe for hot oat cereal. I don't know if that sounds very good to me. Hot oats cereal? Why don't you just call it oatmeal? Whatever. Calls for 2 cups. That isn't cereal, that's oatmeal. What are they talking about? 2 cups of water. And for 1/3 cup. Why is 1/3 way over there? No idea. 1/3 cup of dry oats. And we're being asked here how many cups of dry oats would be used with 3 cups of water. So to me, this sounds like a good proportion question. If you have something compared to something, then you're going to try to compare something else compared to something else in a similar way. Here we're comparing cups of water to dry oats. on one side, and then we're going to compare cups of water to dry oats on the other side and make these proportions, or make this proportion, set it equal, set the fractions, the ratios equal to each other to make a proportion. And so it says 2 cups of water, so this is 2 cups of water, is to 1/3 of a cup of oats as, or equals, 3 cups of water is to this unknown amount of dry, not outs, but oats. I'm going to call it X, so a cup or cups of oats. So think about just the numbers now. Think about this and this. Think about this and this. I'm going to cross multiply here. So I would have 2x equals 3 times 1/3. That would just be 1. Sorry, not 3. That would just be 1. And so you would divide by 2 both sides, and that gives you your final answer. You would have 1/2 of a cup of oats with 3 cups of water. Very practical problem. I think you might use something like that in your everyday life in the future. So 1/2 cup of oats, or dry oats, you could say. And that would be the final answer for number 15. So I'm sorry, number 15, I didn't mean to skip you. I hope you don't feel left out or too upset. 17 and 19, hey guys, what's up? We're going to solve you now, or figure out what the answer should be to you. I'm talking to math problems like they have feelings, like they have emotions. Maybe they do. In exercises 17 through 20, use a formula to find the value of the indicated variable for the values given. So here, A equals BH. That looks like the area of a rectangle or of a parallelogram. We're finding A when B equals 12 and H equals 4. So simply plug in 12 and 4. This one's very straightforward. 12 times 4 would be your area, 48. And so this one, it doesn't give you units. You could just leave that number as your answer. Number 19, we've got this messy looking thing with this z-score, but it's simply a matter of plugging in the numbers again. This time I do know z, and so why don't I fill that in? I'm told that z equals 2, so I'm going to just take this equation right here, this formula, and plug in 2 for z. I'm going to plug in for this x bar value. I'm trying to find that, so I'm going to leave that as x bar. Plug in for mu, I've got 100, and I'm dividing this by, it looks like sigma is 3 and n is 16, so I'll plug that in right there. And so let's simplify this. Let's continue this idea going down here. This would be 3 over 4 right there. And so how can I get rid of fractions, or how can I get rid of anything? There's a couple different ways I could approach this problem. I think this is probably the easiest way though. And so if you had just a simpler case of this is not related to any one of these problems in terms of the numbers being used to solve this. But if you had something like this is a more simplified case. If you had something like this, we would have x divided by 2. We could simply multiply both sides by 2 to get rid of the divided by 2 part. That would cancel out here. I'm going to apply that to this problem right here. You have something divided by 3/4, so you can simply multiply by that number right there. That's going to cancel out the divided by 3/4 by multiplying both sides by 3/4. And so that was the easiest way I saw to do this one. I'm going to make this a fraction, put that over 1. You could either cancel, cross cancel right now, which I think I'll do right now. That would be a 1 and a 2. Or you could have multiplied 3 times 2 and put that over 4 times 1. You'd have 6 over 4, which would reduce to the same thing here as 3 times 1 is 3 over 2 times 1 is 2. So you'd have 3 over 2 on this side either way you did that. And so you got x bar here. This cancel with that, but you still have x bar minus 100. You add 100 to both sides. We're taking 100 plus 3/2. And so that means x bar would equal, if you think of 100 plus 3/2, if you want to change this to a decimal, it looks like that's what they've done in the back of the book. That would be okay. I'll show you a few different ways you could get the answer for this. This would be like 1 and 1/2, so you could write it as 101 and 1/2. You could also write it as 101.5. You can even write it as an improper fraction. 2 times 101 would be 202. Plus 1 would be 203. So you'd have 203 over 2. Any one of these answers, if it wasn't specified what way they wanted you to write it, would be acceptable. Let's check out numbers 21 and 23 now. So we're going to solve for y in these equations. So we're trying to get, in other words, we're trying to get y by itself. We're trying to isolate that variable. So first thing I would need to do to get a step closer to that would be to move the x's to the other side of the equation. This would cancel out here and here. I'd be left with negative 9y equals negative 3x plus 18. And then to finalize the problem here, to finally get y all by itself, divide by negative 9, that would be y equals, and then because we have a plus in between here, we're adding or subtracting in between, we can reduce these, but we have to reduce each part separately. And so we would have, this could be reduced to a 1. It looks like I could divide 3 into all of these. So I could reduce this to a 1, I could reduce this to a 3, I could reduce this to a 6. And so my final answer here, we could also say negative divided by negative here would be a positive. But if you do that, I'm going to show you 2 different ways to me that would be acceptable to write the answer. You could have, this would be negative x plus 6 over negative 3. Generally though, you wouldn't see a negative and negative out in front here, so another way to write that would be positive x and a positive 3, but then you'd have to change the sign here. That would have to be a negative 6. You could also write this as, it's like 1x over 3, so you could write it as 1/3 times x, or x over 3 minus 2. So some different ways to write the final answer for that. I'd take any one of these ways as your teacher. They're all equivalent answers though. The book does give this actually as a final answer with the positive sign here and here and a negative sign here. That's like reducing each one of these, or kind of dividing each one by negative 1. And so, yeah, that's kind of acceptable too, but I would prefer to see that reduced actually in the book. So they did that. They gave you 2 different valid answers. They gave you this one as well in the back. I like that one better than that before it's reduced. And then number 23, why don't I do that one over here? I think I'll have enough room to fit that in. 2x minus 3y plus 52 equals 30. So trying to isolate the y, get the y by itself. I'll stick with my ways there and use a different color for the intermediate steps. So I'd have 2x minus 3y. Subtracting 52 gets all the constant terms all together on one side. And then I could subtract 2x here and here. That would leave me with negative 3y equals negative 2x minus 22. These are all negative, and so I could just kind of think of multiplying everything by negative 1 or dividing everything by negative 1. That would leave me with this instead, which I think is a lot easier to deal with. And then finally we can take that and divide everything by 3. You can write it like this if it helps you to think of it like this instead. Here's another way to think of it. I'm dividing everything by 3, so I could divide each part separately by 3. I can think of it like that as well. So there's a couple different acceptable ways to write this one, just like there were here, or a few different ways. You could write this as 2/3 x plus 22/3. If you would have left it as 2x plus 22 and divided all of that by 3, this is not reducible at all, so that's also an acceptable answer. So either one of these 2 things would be totally fine. If you had all negatives, I think you really should change it to all positives instead, talking about what we did up here. Alright, let's check out 25 and 27 now. So we're solving for the variable indicated. 25, we are solving area is length times width. That's what that equation is. We're trying to solve that for w. To do that, just divide both sides by L. Treat these numbers as if they were, or these letters, these variables, as if they were constant terms or coefficients. So if it was like a equals 3w, you divide by 3. If it's a equals lw, you divide by L. And your final answer would be A divided by L. Notice I use cursive L's here and not an L like this because that looks like a 1. I guess it's time to go home. Almost. Just gotta finish this up. I gotta do my homework here. And then L, capital L equals, that is a long bell, that's right, it's the end of the bell. It's the end of the day bell. This is gonna be that. We're trying to solve or get the lowercase l by itself here. And so how could we do that? Well, first I see that dividing everything here by 2, dividing this by 2 and this side by 2, I'd get rid of the 2 right there. So that's one step closer. So we'd have L over 2, uppercase L over 2 would be WH plus LH. And I could subtract WH from both sides. I could also do something else. I'm going to go with subtracting WH from both sides though. Sometimes there's different ways to go about this, but I'm going to subtract WH from both sides here. So subtract WH here and here, that would cancel out there and there. And I'd be left with L over 2 minus WH equals LH. And now to get H by itself, I could divide by L. But before I do that though, I'm going to put these together so they have a common denominator. So I could take this and I could, to get the common denominator here, I could multiply by 2 over 2. So let's see what that yields right there. I'm just going to multiply this term by 2 over 2. So I would have L minus 2WH. And since it's all over 2 now, I could just put the whole thing over 2. So this equals still lowercase l times h. And then finally I could divide both sides by h to get this l by itself. So I'm dividing this by h. But remember, dividing by something is the same as multiplying by. You can write this as h over 1. You could write that as h over 1. Same as multiplying both sides by the reciprocal. And so this would become, or would be the same thing as L minus 2WH over 2 times 1 over h. Dividing by a fraction, same as multiplying by the reciprocal. So we have this equals L. So in the end, you've got times 1 on the top. That's not going to change anything there. So it's L minus 2WH. You'd have that over 2 times h on the bottom, 2h. That would be what lowercase l would equal. Another way to write this, since you can divide each part by 2h, you could write that as L over 2h, and then you've got 2h here and a 2h here, so you would have just minus w. W over 1 would be w. That's an equivalent way to write it. So either one of those is acceptable. Now numbers 29 and 31, let's check those out. We're to lesson 6.4. This is the last lesson we're looking at for this test. 29, it says 8 increased by 2 times x. We're writing the phrase in mathematical terms. So 8 increased by 2 times x. So increased by, that would be the same as adding. So we have 8 plus 2x. You could write it like that. If you wrote 2x plus 8, that would be fine as well. We have 8 increased by 2x. Commutative property of addition says you can switch the order in which you add things. And then number 31, 10 increased by 3 times r. Sounds like the same sort of wording here. So the answer is found in the same way. 10 increased by or added to 3 times r would look like that. You could also write it like this. These other ones, decreased by, you'd be subtracting the difference subtracting again there. Check those ones out. If you're like, I'm not so sure after reading those, I'm not sure so sure I could do those, try them, check your answers in the back. They have all the evens and all the odds in the back for the review. Let's check out 33 and 35 now. So we are writing an equation that can be used to solve the problems and then solve the equation and find the desired values. So let's do 35 or 33 over here first. 4 increased by 3 times the number. 4 increased by plus 3 times the number, let's call that number x, is or equals 22. And now we just solve that for the variable. So this would be canceling out here and here, we'd have 3x equals 18. Divide both sides by 3, and you get your answer. But the variable, the value you were looking for would be x equals 6, or whatever letter you chose. Your answer should be 6. Number 35, 5 times the difference of a number and 4 is 45. So is 45, I know this is going to equal 45. 5 times the difference of a number and 4. So we're taking 5 times, and then the difference of a number and 4. That would look like we're subtracting 4 from the number itself, from x. So 5 times the difference of a number and 4. The way it's worded, this would be the way we'd want to do that. We wouldn't want to do 5x without the parentheses, because we have to take the way it's worded, take the difference of a number and 4 first, multiply that times 5. From there, we are going to take the 5, distribute that through. We have 5x minus 20 equals 45. We can add 20 to both sides of the equation. It gets you 5x equals 65. That would have canceled there and there. Divide both sides by 5, and you got your final answer. You got that x equals 13. Right, we're on the home stretch here. One more that we're going to do together. 2 more that we're going to do together. 37 and 39. 37. We are doing some modeling. This orangutan looks like he's doing some modeling, or is that orangutan? I think it is. I think so. I don't think it's another type of monkey or whatever. I think that's orangutan, but modeling. Jim, this is mathematical modeling, not like, oh, I look so pretty. Not like that. Investing. Jim Lawton receives an inheritance of $15,000. If he wants to invest twice as much money in mutual funds as bonds, how much should he invest in mutual funds? When we do problems like this, you want to pick a variable and say let this represent a certain amount, and then set up an equation. So let's say, what do we want to call my variable? X. We could always go with X. That's a good fallback. But let's say twice as much as bonds. Let's say B is the amount invested in bonds. That sounds like a good one to use there. If that's true, then you could set up this equation. We can say that the amount invested in bonds, B, plus this amount in mutual funds, we want to invest twice as much money in mutual funds as bonds. So we're going to take this plus 2B. This is the amount invested. 2B is the amount invested in mutual funds. I guess you could kind of call that M, but then you could replace M with 2B because you're investing twice as much. So we have B plus 2B would equal 15,000. From there, this one, yeah, you probably could have done a little trial error, just thought about, okay, twice as much, and just plugged in different numbers and tried to figure out which one would be 2 times bigger. But we want to get in the good habit of being able to set up an equation using variables like this, because it gets more and more complex as you move on in math, and you can't just do that trial and error in your head later on. There's just too much going on. So from there, divide both sides by 3, and you get that B equals 5,000, but the question asks, so always go back to the question, see what it asks. It says, how much should he invest in mutual funds? So in mutual funds, we could put therefore, he should invest 2 times that, which is $10,000 in mutual funds. And so that's it for number 37. Looks like they used X instead of B there. It says to write the equation first in the directions and then find the solution. So we do need to have this to start. This is part of our answer, something like this, and then solve that for your variable. I used B instead of X, but you could have used X as well. Now, it does say in the back, it gives you both bonds and mutual funds, but the question only asks how much should he invest in mutual funds. So that's really the only answer you need to answer the question that they asked. Let's see if I have enough room to fit in 39 here. I'm going to try to make this work. So zoo animals, and according to the 2003 World Almanac, the number of species at the San Diego Zoo, really cool place. If you've never been there, you should go check it out. It is 140 more than 2 times the number of species at the Philadelphia Zoo. So it sounds like there's a lot more animals at San Diego Zoo than the Philadelphia Zoo. The sum of the species at San Diego Zoo and Philadelphia Zoo is 1130, determining the number of species at each zoo. And so it looks like, oh, we'll go with X. We'll be boring in this one. Let's say X is the species, the number of species. Now, what would make more sense to say? Is that the number of species in the Philadelphia Zoo or the San Diego Zoo? Well, since the San Diego Zoo has 2 times more plus 140 more than 2 times the number in the Philadelphia Zoo, I think it would make a lot more sense to say that X is the species, number of species in the Philly Zoo, the Philadelphia Zoo. Philadelphia Zoo, there we go. So if that's the case, then you can say that this would be the Philadelphia Zoo right here, X plus, and then this part would be the San Diego Zoo, 2X plus 140. So this is the San Diego Zoo right here. So that setup says the sum of all the species, at both zoos together is 1130. So there's our equation. That's our setup. From there, it's a matter of combining like terms. 3x here, x plus 2x. I'm going to have that plus 140 is 1130. There we go. And then subtract your 140, divide by 3. You'll get the number at the Philadelphia Zoo, at least. Maybe with 3x equals, let's see, what would that be? That'd be 990. Divide both sides by 3, and that would mean you'd have x, which is the number at the Philadelphia Zoo. X is 330 species at the, I'll abbreviate it like that, the Philadelphia Zoo, and that means that the San Diego Zoo you have, or I can say there are 2 times 330 plus 140, that would be 660 plus 140. 660 plus 140 would be 820. If you put those together, did I get that right? Something's off. No, it would be 800, I'm sorry. 660 plus 140, 800, there we go. It would be 800 species at the San Diego Zoo. I'll put SD Zoo right there. And if you put this one and this one together, 800 plus 330, it equals 1130, just like it should. And so that'll do it for us. That'll do it for me, and hopefully for you as well. Hopefully you found that helpful with any of the problems that you needed some extra help on. I'll go back and review those. Be ready for the test coming up, and I will hopefully see you guys later. Hopefully you have a good day as well. Hasta la pasta.